Welcome back, everyone. Today, we will continue our illustration of transforming public data into business intelligence. Now, why would we do something like this? Well, imagine a wealth of insights you can obtain by looking at a market from multiple perspectives, particularly a market involving the movement of raw materials that are being classified as waste. This waste ultimately gets transformed into valuable commodities. Hence, nothing is ever wasted. Also, if you're a transporter of waste, imagine how much you can reduce transportation costs and liabilities. Having intimate details on the disposal and treatment facilities in your area and throughout the nation leads to many advantages. So we have downloaded the RCRA Biennial Report from the EPA website, and we are ready to extract the data from the flat files and load it into our database in the cloud. Your database can be located in the cloud infrastructure on AWS, Amazon Web Services, Microsoft Azure, or any IT infrastructure, or even on your computer. You choose. But first, we must load the flat file specifications into our database. This will allow us to use an ETL tool to extract, transform, and load the data. The flat file specifications will guide the ETL tool in interpreting the structure of the data in the file so it can be loaded seamlessly in our database in the cloud. In this example, we will use our Cloud Database Management application called BPM to design the database model and display this data visually once it's loaded. First, let's create a data table called module. This table will be used as a container for all the RCRA data modules we want to extract from the EPA website. Next, we'll create a data table called RCRA Data Table to store all the different types of data for a specific module. In the case of the Biennial Report, we have 7 data tables within the module: reporting, management method, GM waste code, BR waste code, source code, waste minimization, form code. Each table has a file specification and is associated with one or more flat files. So we'll need to create a table to store the associated file specification and a separate table to store the names of the flat files for a specific RCRA data table. This is very helpful because, 1, it enables you to keep track of what files belongs to what modules. 2, it enables you to automate the process of extracting, transforming, and loading that data with an ETL tool. In this example, the Biennial Report module has 3 flat files and 59 data definitions within its specification. Loading the specification into the database can be easily done by copying and pasting the specification from the EPA website into an Excel spreadsheet, then loading the spreadsheet into the database. Once the specification is loaded, use your ETL tool to extract the data from the flat files by simply reading the data definitions you've stored in your database. But hold up, wait a minute. Now, there are a few things we need to do before extracting and loading the data into the database. We must first create the relational lookup tables that will help us organize that data. We want to create a separate table for, tables like state, right? And you'll notice in the flat file that there are duplicate entries for EPA handler ID, state, waste code, form code, industry, etc. We want a separate data table for EPA handler ID. We want a separate table for waste code, for industry, for state, etc. We want to create a separate table for each of these tables. This way, in the Biennial Report entries, we can reference the primary key of each of these data elements to optimize query performance and reduce data redundancy. This is called data normalization. Now that we have the specification and all the tables we need for the Biennial Report module in our database, we can now extract the data from the flat file and load it into the cloud. In our next example, we will show you how to visually display this data as business intelligence and how it can be very useful to you and your organization.